Hello grade 10 learners! Welcome back to my YouTube channel. This is Mr. Brian Bulacton again at your service. For today, I will be making a tutorial video for Module 6 which is about finding the end term of a geometric sequence and geometric means. So stay tuned and learn with me. The first task that we have here, the instruction is find the indicated term or terms of the following geometric sequence. Let's start with number 1. We are given 3, 6, 12, blank, and blank. So in this case, to be able to give the unknown terms for this geometric sequence, we need to get a common ratio. And to get a common ratio, all you have to do is just to choose any two consecutive terms of the given, and then get the quotient or the ratio. For this case, you can have 6 over 3, or you can have 12 over 6. So I'll choose 6 over 3. So 6 over 3, or 6 divided by 3 is equivalent to 2. If you have the common ratio, as soon as you have the common ratio, you multiply the common ratio to the last known term, which is 12. So you will have 12, multiply it by your common ratio 2, and that will give you 24. So that is what you're going to write on the blank. Then, to solve for the next term, you'll have 24, because 24 now is the last known term. Multiply it by the common ratio 2, and that will give you 48. So 48 will be written here. So that's how simple it is to get the unknown terms of a given geometric sequence. Okay. Now let's proceed to number 2. We're given 10, 5, 5 halves, and so on, and we need to get a sub 6. So we need to get the 6th term. So we can actually do what we did in number 1, just like what we did in number 1. We will be making blanks, and then we'll stop at the 6th term to get our a sub 6. But to make things simpler, because in the coming examples or in the next examples, succeeding examples, we'll be looking for more terms, this is the time or the perfect time to use the formula for geometric sequence, the end term of geometric sequence. So to find the end term of a geometric sequence, we will be using the formula a sub n is equal to a sub 1 r to the exponent of n minus 1, where your a sub n is your end term, your a sub 1 is your first term, your r is the common ratio, and n is the number of terms. So this is the formula that we will be using in finding the end term of the geometric sequence, or in finding the n, in finding the r, or the a sub 1. So this will be the standard formula for the end term of the geometric sequence. Now let's go back to our example number 2. We are given 10, 5, 5 halves, and we are going to find a sub 6. So you start with a given. You start with a formula. You can actually identify the given in this example. So your given will be a sub 1. What is our a sub 1? A sub 1 is 10. Then the common ratio, we'll be needing the common ratio here because that's in our formula. Just choose any two consecutive terms. So I'll be choosing this. So you will have 5 over 10. Reduce to lowest term. 5 over 10 is divisible. 5 and 10 are both divisible by 5. 5 divided by 5 is 1. Then 10 divided by 5 is 2. So our common ratio is equal to 1/2. Then get the value of your n. Your value over n is actually the subscript of your nth term. Our nth term is a sub 6, therefore our n is 6. So there will be 6 terms in the given geometric sequence. Now, our unknown is, of course, our a sub 6. So this is our unknown. And to solve, allow me to erase the formula on this side of the board, and let's write, or I'll be writing here the solution. So for your solution, you always start with the formula. A sub n is equal to a sub 1 r to the exponent of n minus 1. You substitute your a sub n with your n term, and that is your unknown. A sub 6 is equal to, your a sub 1 is 10, you write 10 here. Your r is 1/2, so you write 1/2. Raised to the exponent of your n is 6, so 6 minus 1. So you have noticed that our common ratio is a fraction. So since the common ratio is a fraction, that means that the numbers are decreasing in value. So you have 10, then 5, it's decreasing, then 5/2. So expect that your a sub 6 is a smaller, or it is actually the smallest value in the given geometric sequence. So let us simplify it further. This will become 10 times 1/2 to the exponent of 5. Copy, 10. So you will perform first r to the exponent of your n minus 1. So you have to perform this before you multiply 10. Okay? So 1/2 to the exponent of 5, that means 1 will have an exponent of 5 because you're going to distribute that by the law of exponent over 2 to the exponent of 5. Simplify it further. You will have 10 times. 1 will be multiplied by itself 5 times. So 1 times 1 is 1 times 1 times 1 times 1 is just equal to 1. So 1 multiplied by itself is always equal to 1. Now 2 to the exponent of 5 means 2 will be multiplied 5 times by itself. So 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32. So you will have 32 here. 10 times 1 over 32. So let us continue the solution on this part. So this is equal to, you multiply 10 to the numerator. Because 10 is a whole number, it is understood to have a denominator. It is understood to have a denominator of 1. And in the law of multiplying fractions, or rule in multiplying fractions, numerator to numerator, then denominator to denominator. So 10 times 1 is 10 over 1 times 32 is 32. 10 over 32 is reducible. So you're going to reduce it by what number? Both are divisible by 2. So you divide this by 2, you divide this also by 2. So 10 divided by 2 is 5. Then over 32 divided by 2 is 16. 5 and 16 don't have any more common factors because 5 is a prime number. Therefore, 5 over 16 is our 6th term. So this is now our 6th term, or it is the 6th number in the geometric sequence. Now let's have example number 3, 1, 3, 9, and so on, and we're going to find a sub 9. So, since we'll be using the formula for geometric sequence to find the n term, which is our a sub 9, we need to identify our given. But actually, if you are already master in determining the given in your mind, you may not jot down the given. So, our a sub 1 is equal to, of course, 1. And then our r is equal to our common ratio. You choose any two consecutive. So, 3 over 1 is equal to 3. So the common ratio is a whole number. That means the numbers in the sequence or in the geometric sequence are increasing. So you notice 1, then you have 3, and then 9. So it's really increasing, or the trend. Yes, the trend of the numbers is increasing. Now, what is our n? Our n is the subscript of our nth term, and that is 9. Our unknown is, of course, our a sub 9. So it is our unknown. So proceed now to solving. So again, in our solution, you always start with the formula. A sub n is equal to a sub 1 r to the exponent of n minus 1. Then substitute. Our a sub n will be replaced by a sub 9. It is equal to a sub 1. Our a sub 1 is 1 times r, which is 3, raised to the exponent of 9 minus 1. So it should be written as exponent. Do not write 9 minus 1 beside 3 because it would give us a different meaning. So it should be written small on the upper right side of 3 to denote that it's exponent. It's an exponent. So you continue. 1 then times 3 to the exponent of 8. So let us simplify first. 3 to the exponent of 8. So 3 will be multiplied by itself 8 times. Okay? So 3 times 3 is 9, times 3, 27, times 3, 81, times 3, 243, times 3, 729, times 3 is 2187, and then times 3, you will have 6561. 6561. You can also check it in your calculator. Just multiply 3 by itself 8 times. Just to make sure that we'll get 6561. So again, this is how we'll do it. 3 times 3, 9, times 3, 27, times 3, 81, times 3, 243, times 3, 729, times 3. So that would be 2187, and then times 3 is 6561. So 6,561 times 1 is, of course, 6,561. So this is our a sub 9, or our 9th term. Now let's have the fourth example. 2, negative 1, 1/2, and so on. And then we're going to find a sub 10. So start with the given. What is our a sub 1 here? Our a sub 1 is obviously 2. Our common ratio will be negative 1 over 2. So that's our common ratio. The common ratio is a negative fraction. So that expect that the numbers will be in descending order. So negative 1/2 because it's fractional. And then our n is equal to the subscript. How many terms are there in the sequence? There are 10 terms. And of course, our unknown is a sub 10. So it is our unknown. So let us now solve. As soon as you're through jotting down the given, proceed to the solution, and of course, start with the formula. A sub n is equal to a sub 1 r to the exponent of n minus 1. And then what is our a sub n? It will be replaced by a sub 10 because it is our nth term. A sub 1 is equal to 2. Our r is equal to negative 1/2 raised to the exponent of our n is 10 minus 1. You simplify it further, it will give you 2 times negative 1/2 raised to the exponent of 9. This exponent 9 will be distributed to the numerator and the denominator of the fraction as exponent. So this will become 2 times negative 1 to the exponent of 9 over 2 to the exponent of 9. Now let's simplify. So you will have 2 times negative 1 will be multiplied by itself 9 times. Okay? 9 times. So, negative 1 times negative 1, positive 1 times negative 1, negative 1 times negative 1, positive, negative, positive, negative, positive, negative. So, negative 1 to the exponent of 9 is negative 1. So, 1 or negative 1 raised to an odd exponent is always negative. If it is raised to an even exponent, it becomes positive. So negative 1 is the result all over 2 to the exponent of 9. So let's try 2 to the exponent of 9. 2 times 2, 4, times 2, 8, times 2, 16, times 2, 32, times 2, 64, times 2, 128, times 2, 256, times 2 is 512. So that is how you do it. 512. Now let us simplify it further. So to simplify it further, I'll just write here the continuation. You will multiply 2 to the numerator because 2 is a whole number. 2 times negative 1 is negative 2 over 512. Negative 2 and 512 are both divisible by 2. So you divide both the numerator and the denominator by 2. You divide it by 2, then you divide it also by 2. Negative 2 divided by 2 is negative 1 over 512 divided by 2 is 256. So negative 1 over 256 is our A sub 10. And there you have it, guys. So simple. So that's how simple you find the end term of a geometric sequence. Are we over? No. The answer is no. We're not yet done for Module 6 because we still have finding the geometric means. So please stay tuned. You look for the other video. There will be a part 2 of this video that I will make, that I will be posting after this. So stay tuned and learn with me.